Okay, so last meeting, we started our discussion sa hydrogen atom. Okay, so the way we modeled yung hydrogen atom was a single electron and a single proton, positive tsaka negative charge in space, and they are modeled using an electrostatic potential, which is proportional to 1 over r. Okay, so ang approach natin is we started with the Schrodinger equation. Okay, we used the time-independent Schrodinger equation in this case kasi hindi naman natin, or yung potential has no time dependence, di ba? And hindi naman natin, at least for now, hindi natin gusto malaman kung anong nangyayari sa kanya over time. So gusto lang natin malaman kung anong klaseng behavior meron siya over space. So, diyan tayo nagsimula sa Schrodinger equation. So, this time-independent na Schrodinger equation. We also said na tawag dito, it will be easier to model yung hydrogen atom if we use a spherical polar coordinate system. Okay, kaya dito, gumagamit tayo ng spherical polar coordinate system para i-model yung hydrogen atom. Okay, so to solve this differential equation, so this is actually a second order differential equation, we use yung technique na separation of variables. Okay, and last time we said na yung ating wave function, which is dependent on radial, on the radius, the azimuthal, and the polar angle. Okay, ay pwede natin i-separate into two functions. Okay, yung unang function is dependent only on the radial, tawag dito, on the radial component. And then yung pangalawang function is dependent on on both the polar tsaka azimuthal angle. Okay? And nung ginawa natin yon, we ended up with two differential equations. Okay? The first differential equation is dependent on r, on the radius alone. And then the second differential equation is dependent on both the azimuthal and the polar angles. And using the separation of variables technique, we equate each of these equations to a certain constant. And sinabi natin na yung constant na gagamitin natin ay equal sa L times L plus 1. So we equated yung first na differential equation to L times L plus 1, yung radial component to L times L plus 1, and then yung sabihin natin angular component kasi 'di ba it takes both yung polar at saka azimuthal angle. So this is the angular component. Inequate natin yan to negative L times L plus 1. Okay, so we write this as the radial component and this is the angular component. Okay, so isolve muna natin yung angular component. Now, notice na yung angular component ay merong anong tawag dito, azimuthal tsaka polar angles. Okay, so in this case, tawag dito, gagamitan ulit natin ito ng separation of variables. Okay, to separate yung angular at saka polar components. So, ang gagawin natin is yung y. Okay. So again, we use the separation of variables technique. Okay. Okay, to separate it into two functions. First, into a function that is dependent only on theta. So this is capital theta, okay, as a function of small theta. And then this is capital phi, yeah, as a function of small phi. Okay, so when we do that dun sa angular component, okay, anong mangyayari? So we have Okay, so we have 1 over capital theta and then capital phi times 1 over sine theta, and then partial with respect to theta. So ibig sabihin, this will be a total derivative with respect to capital theta. Okay, tapos dito magkakaroon tayo ng capital phi. Okay, plus, ito naman ay capital theta over sine squared theta times yung second derivative with respect to phi ng capital phi. Okay? And this is equal to negative L times L plus 1. Okay, so now, so ang gagawin ko ay ililipat ko to dito. So this will become capital theta and then capital phi. Okay, tapos, ang gagawin natin ay ipagsamahin natin lahat ng mga theta components, right? Actually, divide muna natin to by, divide muna natin everything by theta and capital phi. Okay, so what we'll end up with is 1 over sine theta tapos 1 over theta, capital theta, and then sine theta, d theta plus 1 over capital phi, sine squared theta, d squared phi, phi, equals to negative L times L plus 1. But we also need to multiply it by sine squared theta, okay, para ma-cancel ito, or para matanggal natin ito at malipat dun sa kabila. Okay? So, then this will become sine theta, tapos ito mawawala. Okay, magka-cancel. So, plus, ano na lang to, 1 over capital phi. Okay? And this is sine squared theta. So now we have etong part na to, which is dependent only on theta. Okay, and then itong part na to, which is dependent only on phi. Okay, so if we rewrite everything, then we get 1 over capital theta sine theta d theta capital theta plus L times L plus 1 sine squared theta. Okay, so yan yung theta component and then plus 1 over capital phi d squared phi ng capital phi equal to 0. Okay, so you have yung azimuthal component, yung first part, and then yung second part ay yung tawag dito polar component. Okay. Okay, so as yung ginagawa natin sa sa separation of variables, we equate each of these to a constant. Okay, and yung constant na pag-equate natin diyan ay m squared. Okay? So it will become obvious kung bakit yun yung constant na gagamitin natin. So we equate this to m squared and we equate this one to negative m squared. Okay, remember na dapat yung sum nila ay 0 kaya negative m squared yan. Okay, so yung ating first equation will then become sine theta or yung azimuthal component Okay, ng ating solution, azimuthal na solution will become this L times L plus 1 sine squared theta and then capital theta equals sa M squared capital theta. Okay, so ito yung azimuthal component. Tama ba? Azimuthal. Theta is the polar pala, sorry. Polar. So this is the polar, okay, component. And then, ito naman pangalawa is d squared d phi squared capital phi equals a negative m squared phi. So ito yung azimuthal, ito yung along the xy plane. And this is actually easily solvable. Okay, makikita nyo na it's nothing but this. Diba? So madali siyang ma-solve and yung solution, okay, yung solution ng differential equation na yan, okay, will give you capital phi as a function of small phi equal to exponential I m phi. Now, makikita niyo kung bakit m squared yung pinili natin dito kasi if we choose that or by choosing m squared, we are able to write yung azimuthal na solution in this manner. Okay? Okay. So, ano itong azimuthal na solution na to? Tingnan muna natin yung solution. So, ito yung graph that describes yung mga angles na yan. And yung azimuthal solution is along the xy plane. Itong pi. Okay? Is along the xy plane. Okay, makikita natin na tawag dito, if you go around the xy plane, then after one cycle, babalik ka lang din sa sa same na solution. Okay, so if you go around one cycle or 2 pi radians, okay, then you get exactly the same solution. Okay? And yun yung magiging boundary condition natin for this differential equation. Okay, so yung isang boundary condition natin is that yung capital phi na to, okay, if we add 2 pi to that, we'll end up with the same solution. So in other words, yung exponential I m phi plus 2 pi, okay, will be equal to the exponential I m phi. Okay. So this means na yung exponential I 2 pi m ay dapat equal sa 1. Right? Kasi exponential I m phi, then exponential I 2 pi m ay equal sa exponential I m phi. And then syempre pag magka-cancel to, magiging equal yan sa 1. Okay, so anong tawag dito? Anong condition ngayon para ma-satisfy ito? So, if we go to the next page, so we write exponential I or ganito lang, 2 pi I m equals sa 1. Okay, so anong condition dito? So ang condition is dapat m is equal to 0, okay, or plus or minus 1, plus or minus 2, plus or minus 3, and so on and so forth. Okay? So, immediately, makikita natin na yung dito, yung m ay takes on certain values certain values lang. Yeah, actually, it takes on integer values. So it's not continuous, it's discrete. So we can say na yung m is quantized. Okay, and binanggit na natin to last meeting kung ano yung m na to. So itong m na to is the magnetic quantum number. Okay? And i-discuss natin yung significance ng magnetic quantum na yan, number na yan, in a little bit after natin mag-derive yung azimuth, polar component. Okay, yung equation or yung solution for the polar component. Okay? Okay, any questions at this point? Okay. So, um, so nakuha na natin or isipin niyo yung ano no, isipin niyo yung nangyari dito no. So we started with Schrodinger's equation and then it turns out na merong tatlong components ito. Itong Schrodinger equation, yung radial, azimuthal at saka polar. And now we have solved yung azimuthal component and we saw na from that solution of the differential equation, uh, nakakuha tayo ng isang quantum number, which means na yung behavior okay, ng hydrogen atom with respect to that quantum number, okay, or with respect to yung azimuthal or yung azimuthal na angle is quantized. Okay, so dito nakikita na natin yung simula ng pagiging quantum tawag dito or quantization ng hydrogen, ng behavior ng hydrogen atom. And it's in terms right now it's in terms of this magnetic quantum number. Okay, so now let's go to the azimuthal component. So yung azimuthal component is given by sine theta, sine 1 over sine theta. Sorry. Aha, wait. Meron akong maling sinulat dito. May kulang. Ayun. Naku. Correct ko to para yan. Okay. Otherwise kasi magka-cancel lang yung sine theta dyan. So 1 over sine theta d theta. And then ito ay sine theta d theta. And then ito rin ay 1 over capital theta. 1 over sine theta d theta. Okay, and ano nangyari dito? So ito naman ay sine theta d theta. And then ito ay sine theta d theta. Okay? Okay, so sine theta d theta, then sine theta d theta, capital theta, okay, plus L times L plus 1, okay, sine squared theta, and then capital theta. Okay, and then equal to sa m squared. M squared, wait. Okay, m squared and then meron tayong theta doon, of course. So, capital theta. Okay. So, ililipat ko lang actually yung m squared sa kabilang side. So, para mas mabilis tayo. Magiging m squared, theta yan. Okay, tanggalin ko lang tong theta dito. And then, lagay ko to sa brackets. Irong natin konti yung m squared, capital theta, and then equal yan sa 0. Okay, so now we have another differential equation. Okay, and tawag dito, it may or may not be familiar sa inyo, but I did ask you to take a look at yung mga some functions last meeting kay dun sa ARFCAN, and I hope you were able to tawag dito study yung mga functions na yun, or at least take a look at yung mga functions na yun. But yung magiging solution dito, okay, is capital theta, okay, capital theta equals A, which is a normalization constant, okay, and then P sub L super M, and then cosine of theta. Okay, kung saan itong P sub L super M ay tinatawag na associated Legendre function or Legendre polynomial. Okay, sorry, Legendre function. Okay, now that is actually written as okay, 1 minus x squared, okay, raised to the absolute value of m over 2 d dx. Okay. Okay. M, absolute value ng mth derivative ng PL of x. And ito namang PL of x, P sub L of x is the Lth Legendre polynomial. And that is given by this one, 1 over 2 to the L factorial, d dx to the L, x squared minus 1 to the L. Okay, so emphasize ko lang na ito ang solution. Okay. Okay, so pag sinusulat niyo yung final answer, yan ang dapat yung isulat na final answer. Okay. Hindi lang yung mga Legendre function tsaka Legendre polynomial. Okay? Okay, so sige, tignan natin kung ano yung first few polynomials dito. So let's say for L equals 0. Okay, ano ang makukuha nating Legendre polynomial? Siyempre, kailangan muna natin kunin yung Legendre polynomial bago yung associated Legendre function, right? Okay, so yung Legendre polynomial dito, so for L equals 0, it will be P0 of x equals okay, so based on this, so it's 1 over 2, by 1 over 2 to the 0, okay, and then 0 factorial, so 1. And then 0th derivative, so wala. And then x squared minus 1 raised to the 0. So that gives us simply 1. Okay? Okay, now for L equals 1, then we have P1 of x, okay, equal na ito sa 1 over 2 to the 1, okay, and then 1 factorial, so 1 half. And then yung first derivative, okay, ng x squared minus 1. Okay, so ano lang gagawin natin dito? Kukunin natin yung derivative nito. So 1 half, anong derivative niyan? That's 2x or equal siya sa x. Okay. And then, okay, and then, tawag dito. Let's say L equals 2, P2x equals. So 1 over 2 squared, which is 4 times 2 factorial. Anong 2 factorial? So that's 2, so that's 1 over 8. Diba? 2 squared times 2 is 8, so 1 over 8. And then second derivative, okay, ng x squared minus 1 squared. Okay, so this is equal to 1 over 8. Second derivative, okay, ng x squared minus 1. So that's x to the 4th minus 2, x squared plus 1. Okay, so equal to so 1/8. Okay, second derivative. Okay, kunin natin diretso. Kaya niyo natin yan, di ba? Second derivative ng x to the fourth. So first derivative is 3x squared, and then ang second derivative is 12x squared. Sorry, 4x cube, and then second derivative ay 12x squared. Okay, so 12x squared minus. Okay, anong second derivative niyan? So that's 4x and then 4. So pag simplify natin, okay, factor out 4. Okay, so this will become 1/2. Okay, tapos 3x squared minus 1. Okay. Now, okay, dun sa table 4.1, hindi pa to. Okay, so you can derive yung mga first few Lejeune polynomial. Okay. Wait, tayo sabi rito table 3.1. Okay, so nandoon ang first few Lejeune polynomials sa table 3.1, chapter 3. Okay, anyway, so straightforward naman yung niyan, yung pag-derive. Okay, so now nakuha na natin yung Lejeune polynomial. Paano natin siya gagamitin ngayon dun sa Lejeune function? Okay. So let's tawag dito. Let's start with P with L equals 2. Okay, so ang tinitignan naman natin dito ay yung Lejeune function. Okay, so ibig ko sabihin, let's start with this P2, and then yung M is 0. Okay, so just for clarity. So we let L be equal to 2, and then yung M ay 0. So ibig sabihin P2 0 of X. Okay, ito yung equation na ginagamit natin. Okay. So P2 0 of X equals sa 1 minus x squared raised to the m over 2. So this is 1 minus x squared raised to the 0. So that's simply 1. So pwede ko nang tanggalin yan. And then 0th derivative ng PL of x. Ang P2 of x is 1/2 3x squared minus 1. Okay, so now remember na yung solution is in this form. So ang gagawin nyo lang basically is lahat ng x dito, papalitan nyo lang ng cosine theta. So yung solution for this particular state, okay, is P or A, tapos P20 ng cosine theta. Remember, you're just going to replace x with cosine. Okay, so equal to 1/2 3 cosine squared theta minus 1. Okay, times A. Okay, so yan yung solution. Okay, for this particular state. Now, sinasabi ko na na state ito kasi kung papansinin niyo, ginagamit lang natin dito ay ginagamit natin ng values ng L ay integer values lang din. Now, bakit integer values lang? Bakit hindi tayo pwedeng gumamit ng Well, of course, mathematically, hindi naman tayo pwedeng mag-take ng derivative. Okay, tawag dito ng non-integer values, right? Okay, so parang mathematically that doesn't make sense. And yun din yung definition ng Lejeune polynomial tsaka Lejeune function. Okay, so integer values lang din. And now we now have actually two quantum quantum numbers. Okay? So yung quantum numbers na ito, ang quantum number na L, okay, ay tinatawag natin na uh, orbital angular momentum quantum number. Okay? And mag-make sense yan mamaya. Okay, when we analyze yung magiging results. So L is the orbital angular momentum quantum number. Okay, it's the orbital angular momentum quantum number. It describes yung orbital angular momentum. Okay, and then pag sinabi orbital angular momentum, kasi yung electron umiikot around the nucleus. Okay, so meron siyang angular momentum. Okay, so it's orbiting around the nucleus and merong yung pag-orbit niya ay merong angular momentum. So yun yung orbital angular momentum. And it turns out na it's also quantized. So ang tawag dito, yung behavior nila along the xy plane plus yung orbital angular momentum, they're both quantized. Okay, so ngayon nakikita na natin yung quantization, quantized nature ng hydrogen atom. Okay, so tignan naman natin for example yung L equals 2 tsaka M equals 1. Okay, so for L equals 2 and M equals 1, okay, ano lang lalabas dito? P2 and then 1 of x. So 1 minus x squared, and then remember this is absolute value ng M, which is now 1 equal to 1, and then 2, and then derivative, and then absolute value ng M, okay? Tapos, PL of x, so P2 of x. Ang P2 of x is 1 half, tapos 3x squared minus 1. Okay, so P21 of x ay equal sa 1 minus x squared, okay, and then square root niyan. Okay, so 1 half, and then yung first derivative, okay, lagay ko na yung 2 sa labas, first derivative ng 3x squared minus 1. So P21 of x ay equals to 1 half 1 minus x squared raised to the 1 half, and then first derivative nito ay 6x. Okay, so pag sinimplify pa natin further, this will be 1 minus x squared raised to the 1 half times 3x. So P21 of x. Now we replace, okay, yung solution nito is A P21 of cosine theta. So this will become A times 1 minus cosine squared theta raised to the 1 half, okay, times 3 cosine theta. Okay. Ano ba ang 1 minus cosine squared theta? So that's sine squared theta, and then kunin mo yung square root and then sine theta. So this will be 3a sine theta cosine theta. Okay. So this is the solution for the case where L equals 2, M equals 1. Okay. Now, naglagay dito ng absolute value. Kasi M, if you recall, okay, so naglagay dyan ng absolute value, no? M, if you recall, can be plus or minus 1. Okay? So, tawag dito. So, regardless kung ano yung sign nung M, then, anong tawag dito, hindi ka pwedeng, parati mong kukunin yung absolute value nun. Okay, now let's evaluate P22. Okay, so P22, green. Okay. So, ibig sabihin, L equals 2, M equals 2. So, in this case, it's P22 of x equals, okay, so 1 minus x squared, and then absolute value ng 2 divided by 2. Okay. And then, ito naman ay second derivative, okay, ng, okay, 1 half, and then 3x squared minus 1. Okay, so simplifying that, we get 1 half. Okay, so 1 minus x squared lang. Okay, and then yung derivative. Okay, so second derivative ng 3x squared. So that's 6x and then 6. So this means na ito magiging P22 of x equal lang to sa 3 times 1 minus x squared. Okay, and then yung solution nito ngayon, in terms of theta, is P22 cosine theta. So A times, or 3A times 1 minus cosine squared theta, okay, or 3A sine squared theta. Okay, so yan ang solution for this step. Okay, any questions so far? Okay, can we go to m equals 3? Pwede ba natin makuha yung L equals 2 tsaka m equals 3? Well, kung mapapansin nyo, hindi natin pwede makuha yon kasi we have this expression. Okay, so for P2 of x. So, ibig sabihin kasi if you take the third derivative of that, then the expression will become 0. Okay, and regardless kung ano yung value ng L na nilalagay nyo dyan, okay, yung M will always be, tawag dito, will not exceed yung value ng L. Okay, so meron tayong condition ngayon that M, the absolute value of M, okay, ay walang solution for tawag dito, if it is greater than L. Okay. So in other words, PL of M ay equal to 0. Okay, so ngayon, we have this condition between L at saka M. So, for example, if L equals 0, okay, then M equals 0. And for L equals 1, then we have M equals minus 1, 0, and plus 1. For L equals 2, we have M equals minus 2, minus 1, 0, 1, at saka plus 2. Okay? So, and so on and so forth. So in general, if you have L equals 0, 1, 2, and so on and so forth, then yung M will have values na negative L plus 1, negative L plus 2, okay, hanggang sa 1 or minus 1, 0, plus 1, okay, plus 2, okay, and so on and so forth hanggang sa L minus 1 and then L. Okay, so, ito yung conditions, okay, relating both M and L sa isa't isa. Okay? Okay, now I suppose it should be already apparent sa inyo. Okay, kung paano to related sa chemistry. Kasi if you recall, pinag-usapan natin last meeting, okay, na itong L na ito, okay, ay pwede nating associate with this, with yung SP, D, F, and so on and so forth. Okay, and itong M na ito ay pwede nating associate with with yung kung ilang electrons meron sa isang state. Okay, so for L equals 0, isa lang yung M na pwede. Okay. So for S, iisa lang yung pwedeng state. For L equals 1, meron kang 1, 2, 3. So for P, meron kang 3 possible states. And then for L equals 2, meron kang 1, 2, 3, 4, 5. So that's D, then meron kang 5 possible states. Okay? So ganyan natin siya pwedeng i-relate with chemistry. Now, siguro yung iba sa inyo tatanungin, hindi ba pag S pwede ka maglagay ng 2 electrons at pag P pwede ka maglagay ng 6 na electrons and pag D pwede ka maglagay ng 10. Well, that's true, but at this point meron kasi tayong hindi pa finactor in. Ang hindi pa natin finactor in dito ay yung electronic spin. Okay? So ang meron lang tayo dito is yung quantization ng magnetic quantum number, which describes yung angle or yung behavior along the xy plane, at yung orbital momentum, okay, orbital angular momentum. Okay. So yun pa lang yung kino-consider natin dito. Kaya hindi pa lumalabas dito yung tawag dito yung spin quantum number. Yun ang pag-aaralan natin sa 182. Okay. So for now, ito lang muna yung i-discuss natin. Okay, so ang tawag dito, now we have sort of a full, we can write down a full solution, okay, to this angular component. Remember that this is an angular component. Okay, saan natin nilagay yun? Okay, so dito, di ba nilagay natin? So ito yung actually na-solve pa lang natin, yung angular component. Okay. So, sinabi natin na yung y ay equal sa product ng theta at saka ng phi. Okay, we know what this is. We know that we have an expression for this, and now we have an expression for this. Okay, so isulat na natin yung full expression ng angular. Ng angular component. So pag ginawa natin yan, sinabi natin na y is equal to y is a function of both theta and phi. So equal siya sa product ng capital theta, okay, and capital phi na wave functions. Okay, ang capital theta is A PLM cosine theta, and ito naman ay exponential I M phi. Okay. The only thing left to do is to normalize, okay, yung function na yan. Okay, and tawag dito, once you normalize, you get an expression for A, okay, and meron ka ng full solution for the angular, tawag dito, for the angular component. Okay. So, hindi na natin gagawin yung normalization. Instead, we write out yung full solution. Naturally, since yung theta ay dependent on both L and M, yung solution na ito will also be dependent on values of L and M. So this will be y sub L super M as a function of theta and phi. Okay. And ito yung normalization constant. Well, it's not really a constant. Well, it is a constant, but it involves yung values ng L at saka M. Okay, so 2L plus 1 over 4 pi, okay, and then L minus M, absolute value ng M factorial over L plus absolute value ng M factorial. Okay, so, and then exponential I M phi, and then yung P Lm cosine theta. Okay, na kung saan itong epsilon is -1 to the m for m greater than or equal to 0, and it is just equal to 1, okay, for m less than or equal to 0. Okay, so gawin natin mas compact yun. So yung epsilon ay equal to -1 raised to the m for m greater than or equal to 0 and 1 for m less than or equal to 0. Okay. Now this solution is called a spherical harmonic. Okay, and tawag dito, yung spherical harmonics na ito, will describe yung angular solution ng hydrogen atom. Okay. So sige, let's test it out. Okay, so wait lang. Yung spherical harmonics na solution ay nasa table 4.2, page 128. Okay, page 128 ng book. Okay, so if you want to take a look at that. But let's try out a few of these tawag dito, spherical harmonics. So let's begin muna with L equals 2, M equals 0. Since na-solve naman na natin yun. So L equals 2, M equals 0. So A over 2, 3 cosine squared theta minus 1. Okay, so L equals 2, M equals 0. So M dito is 0, so automatically yung epsilon is already 1. Okay, so, and then yung log ng square root is, ang mangyayari dyan is 2 times L. So 2 times L is 4 plus 1, 5. So 5 over. So 5 over 4 pi. And then L minus M is 0. So L factorial. 2 factorial is 2. And then L plus M is 0. So that's also 2 factorial. So magka-cancel lang yan. So square root of 2L. Wait lang. Square root of 4. L plus M. Okay, so square root of 5 over 4 pi times, yung M is 0, so itong term na to will be just equal to 1. Okay, times, and then 1/2, di ba? Times 3 cosine squared theta minus 1. Yun yung P, ito yung P2 of 0 na cosine theta. Okay, so okay, so this is the y20 theta pi solution. Okay, so ang gagawin ko is ipapasok ko itong 2 dun sa loob ng square root. So what I'll get, so para mawala lahat ng mga constants na. At least magsama-sama lahat ng mga constants. So I'll get 5 over 16 pi and then square root times 3 cosine squared theta minus 1. Okay, so yan yung spherical harmonics for this state. Yan. Okay, now let's try L equals 2, M equals 1. Well, not just 1, but let's say plus or minus 1. Kasi, bakit plus or minus 1? Kasi, alam natin na yung L, for L equals 2, it can have M equals minus 1 at saka plus 1. Okay, so isama na natin pareho kasi total absolute value naman yung ginagamit dyan and yun naman yung lalabas. So in this case, pag m equals greater than 0, then magkakaroon tayo ng epsilon na negative, right? So y2, 1, y2, sorry, plus or minus 1 of theta and phi. Okay, magkakaroon tayo ng, kailangan kong ibaba ito. Okay, magkakaroon tayo ng minus sign. Okay. That's for the case na m is greater than 0. What about for m less than 0? Then yung epsilon natin is 1. Okay, so minus plus of 1. Okay, yan yung epsilon. And then sa loob ng square root. So 2 times L plus 1, that's 5 over 4 pi. And then L minus 1, so that's 2 minus 1, so that's 1 factorial. And then over L plus 1, so that's 3 factorial. So 1 over 3 factorial, that's 1 over 6, right? Times 1 over 6. So 5 over 24 na siya. Okay, so 5 over 24 pi, and then square root. Okay, okay, tapos exponential I, remember this, m is plus or minus 1, so exponential I plus or minus 1, phi, m equals 1. Okay. And then yung p, dito ay yung p2, and then plus or minus 1 of cosine theta. Okay, pero nakuha na natin yan before. Ito yun. Okay, so 3a sine theta, cosine theta. So, okay. So, 3a, wala na yung a kasi ito nga yung normalization, cosine theta, or sine theta, cosine theta. Okay. Okay na? Okay, so, isi-simplify na lang natin itong mga solution to. So, minus plus, ngayon yung 3 papasok ko sa square root. It will give us, anong tawag dito? 9 times 5. Pero yung 45, and then pwede pa natin i-simplify yan. Okay, 15 over 8 pi, square root. Sine theta, cosine theta, exponential, plus or minus I pi. Okay, so yan yung ating solution for L equals 2, M equals plus 1. Okay. Any questions? Questions? Wala. Okay lang. Dali lang. Okay. Let's see. Okay, inisip ko kung mag-diretso na tayo sa radial or magbigay muna tayo ng examples. Well, may mga examples naman na dito na bigay. Okay. Okay, sige. Sige, tingnan natin bigay tayo ng example. Now, before we consider a few more examples, okay. Syempre, tawag dito, we have to check if these solutions are normalized and orthogonal. Okay, and the way to do that is tawag dito, we integrate, diba, yung wave functions ito, yung modulus squared ng wave functions ito over all space, right? And dapat equal yun sa 1. Okay, kasi 'di ba yung probability na makikita mo yung particle over all space should be equal to 1. The particle should be there. Otherwise, ano pang silbi ng pinag-uusapan natin, right? So, kung wala naman yung particle doon, bakit natin pinag-uusapan, right? So, in terms of yung polynomials na ito, in terms of, sorry, yung harmonics na ito, spherical harmonics, we can check yung ano, yung orthonormality. Okay, ibig sabihin normalized at saka orthogonal. Okay, from this equation. So 0 to 2 pi, integral ng 0 to 2 pi, 0 to pi, and then y, yung spherical harmonics ng y, Lm, theta, phi, okay, and then syempre yung star niya, di ba, yung absolute value, sorry, yung complex conjugate. And then y sub L prime, M prime, and then theta, phi. Okay, and then, of course, sine theta, d theta, and then d phi. And dapat equal yan. So d L L prime, and then d M M prime. Okay, so, ibig sabihin lang yan is dapat for all for para maging 1 yan dapat L is equal to L prime and M is equal to M prime. Otherwise, 0 silang lahat, and that makes them orthogonal. Okay? So how do we check for normalization and orthonormalization? Okay, so let's consider, for example, y00. Okay, so sandali. Yung, dali check ko lang yung notes ko. Okay, so ang tinitignan natin ngayon ay yung example or yung problem 4.3. Okay, so ito yung sinasabi ng problem 4.3. Okay, ilipat ko to. And copying ko lang. Ilagay ko dito sa notes natin. Okay, so problem 4.3. Okay. Okay, so problem 4.3. Okay, using equations 4.27, 4.28, and 4.32, construct y0, y00, and y21. Okay, so ano muna ang 4.27? Okay, 4.28. Okay, so para lang klaro, etong Lejeune polynomial, Lejeune function, yun yung 4.27. So this is equation 4.27. Ito naman yung equation 4.28. 28. Okay. So, next is 4.32. Ano equation 4.32? Yung full solution. Okay, so ito. This one. Spherical harmonics. So this is equation 4.30. So check that they are normalized and orthogonal. Okay, so y0, 0. Okay, so y0, 0, theta and phi. Ibig sabihin nito, L equals 0, M equals 0. Okay, alam naman natin yung L equals 0, di ba? So from this equation, M equals 0, so yung epsilon is 0. Okay, 2 times 0 is, 0 plus 1, so 1 over 4 pi. And then 0 factorial over 0 factorial. So meron tayong 1 over 4 pi, square root ng 1 over 4 pi na coefficient. Okay, and then yung P00 cosine theta. Okay, but we already know this, P00. Okay, ang P00, actually hindi pa pala natin alam. Okay, so if we use 4.28, okay, ang P00 of x, 4.27, sorry, ang P00 of x is, so 1 minus x squared raised to the 0, so that's 1. And then 0 derivative ng P0 of x. Pero P0 of x is 1. So ito ay equal lang din sa 1. Okay, so this is just equal to 1 over 4 pi square root. Okay. So, paano natin i-check kung normalize siya? Again, gamitin natin integral. So, from 0 to 2 pi, 0 to pi ng 1 over 4 pi square root, okay, times square root ng 1 over 4 pi. So, mawawala na yung square root yan, right? So, pwede ko na siya actually ilabas. 1 over 4 pi. And then, ang matitira na lang is sine theta d theta. And then d phi. So, this will become 1 over 4 pi. Okay. And 0 to 2 pi ng phi. Diba? So, ito muna. Or kung gusto niyo, ito muna ang isolve niya. Sine theta d theta. Ano integral niyan? That's cosine. 0 to 2 pi. And then cosine theta negative, diba? Negative cosine theta from 0 to pi and then d pi. Okay, so ano ang sagot dyan? So cosine ng pi is negative 1 times 1. So 1 minus 0. So 1 minus negative 1. So that will give us 2. Okay, so yan yung bibigay sa atin. And then, from this integral, ang ibibigay naman sa atin yan is 2 pi. So, we have 2 pi times 2, that's 4 pi, divided by 4 pi. So that means that the integral is equal to 1. So, that's normalized. Okay. Okay. Okay, so let's do y 2, 1, theta, and phi. Okay, so L equals 2, M equals 1. Okay, pero nasolve na natin ito kanina. Okay, so L equals 2, M equals 1. So ito yung sagot. So positive 1 is negative 15 over 8 pi, sine theta, cosine theta, and the exponential I phi. So negative 15 over 8 pi, sine theta, cosine theta, exponential I phi. So, gamit yung orthonormalization condition, okay, we have y 2, 1, 0, theta, phi. And remember, this is asterisk. We take the complex conjugate. Okay, so theta, phi. And then sine theta, d theta, and then d phi. Okay, so from 0 to 2 pi, 0 to pi, we have, so negative times negative is positive, and then yung square root mawawala, so ilalabas na natin 15 over 8 pi. Excuse. And then sine theta, okay, cosine theta, sine squared theta, cosine theta, kasi may sine theta ka pa dyan. Tapos, this will give us exponential negative I phi, and this will give us exponential positive I phi. So, mawawala yung exponential, ang matitira na lang is d theta, and then d phi. Tama ba? Okay. So, yeah. Sorry. So, next step is 15 over 8 pi, and then integral from 0 to pi ng d phi. Tapos integral from 0 to pi ng sine squared theta, cosine theta, d theta. Okay, so if we let u, in this case, if we let u be equal to sine squared theta, then sorry, hindi yan. If we let u be equal to sine theta, then du is equal to cosine theta. Yeah, better yata to. So that will give us 15 over 8 pi. Okay, 0 to 2 pi d phi. Okay, and then integral, okay, ng u squared, okay, sorry, d theta, ng u squared du. Okay, tama. Yung du and then u squared. Okay. And then ano yung limits of integration? Pag zero ito, then this will give us 0. Diba? Pag pi yan, it will give us sine pi, sine 0. Wait. It will also give us sine pi. Okay, teka, nalito na ako. Okay, we just leave it at that. Kasi parang mas okay, so ibabalik din naman natin later yan. So 2 pi and then integral ng u squared du is just 1/2 times integral niya is u cube over 3. Okay, and then okay, tapos ibabalik natin to 15 over 8 pi, 0 to 2 pi. Actually, evaluate na natin yung 0 to 2 pi na yan. So that's 2 pi, so magiging 15 over 4. And then we have sine cube theta, 15 over 12. Pwede natin i-divide by 3, so we have 5 over 4. Sine cube evaluated from 0 to pi. Okay, Anong ibibigay sa atin ito? This will give us 0. Okay, teka, anong ginawa ko dito? Hmm. Ginawa ko, equal naman sila. Okay. Mali, 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 mali. Mali. Sin theta, cosine theta. May sin theta, cosine theta ka dito. May sin theta, cosine theta ka dyan. And of course, mag-square silang lahat. Okay, sine squared theta, cosine squared theta, and then sine theta, d theta, d phi. Okay, so dapat ganyan. Okay. Then, buburahin natin lahat ito. Okay. So, 15 over 8 pi, 0 to 2 pi ng d phi, then 0 to pi ng sine cube theta cosine squared theta d theta. Yan. Okay. So, okay ba? Mas clear ba yan? Okay, so ang gagawin natin ganito. So, 15 over 8 pi, 0 to 2 pi. Okay, so yan ay, ang bibigay sa atin yan is ano? 2 pi, so 15 over 4 na lang siya. And then 0 to pi. Tapos, so yung sine squared, papalitan natin dito ng 1 minus cosine squared theta. Cosine squared theta, d theta. Okay. Tapos, ang mangyayari dyan is 15 over 4, 0 to pi, and then yung first term dito will be cosine squared theta, sine theta, d theta. Okay. And then yung second term is cosine to the fourth theta, sine theta, d theta. Kung ano? So, basically, minultiply lang natin doon. Okay, so, now, if we let u be equal to cosine theta, let's say cosine squared theta, then tawag dito du will be equal to 2 cosine theta. Sorry. If we let u be equal to cosine theta lang, oops. U be equal to cosine theta lang. Okay, so then du is equal to sine theta d theta. So ito yung ating du, yan yung ating du. So itong integral na ito, 0 to pi, will just be u squared du. Okay, minus u to the fourth du. Okay, ang limits of integration ay from 0 to negative 1. Okay, pero hindi na nagmamatter yan at this point kasi babalik din naman natin siya from 1 to negative 1 pala. Kasi babalik din naman natin siya sa sine theta. Okay, so this will become in terms of theta, ibig sabihin. 15 over 4, okay, u to the 3 over 3 minus u to 5th over 5th. Evaluated from 1 to negative 1. Okay, Baka pwede na natin i-diretso. So, -1. Tingnan natin. So, negative. So, may 1/3 and then -1. Okay, tama, no? -1. Okay, minus the 1/5 times -1 minus 1. Okay. So, anong ibibigay sa atin ito? Ito ay -2. Kalimutan ko yung negative sign dito. Yung may negative sign. Okay, so -2/3 tapos -2/5 minus -2/5. Sige. So equal to sa negative. So now we are at -15/4 tapos ano yan? 1/3, 2/3, -2/3. Minus -2/5. Okay. Okay. Tama ba? Gusto ko lang i-double check. So, factor out na natin itong negative signs dito. Para mag-cancel siya with that. So we have 15/4, then 2/3 minus 2/5. Okay, so balik grade 2 tayo. This will become 10 minus 6/15, or 15/4 times 4/15, which is equal to 1. So ibig sabihin normalized. Okay, yung ating wave function. Okay? Okay. So any questions? Okay, so try nyo isolve ito at i-discuss natin sa Wednesday. This one. Okay. Okay, so I'm going to put it here. Okay, para pag in-upload ko to sa notes, ay makikita niyo yung problem. Okay, so try nyo isolve yan. Okay, and discuss natin sa Wednesday. Okay? Okay, sige. Before we leave, or before you leave pala, tawag dito, meron ba kayong concerns related sa exam sa Monday? Okay. So yung exam nyo sa Monday ay 9 to 12 sa IB 105. Okay, so book na yung room na yon for us. Okay, meron ba kayong concerns regarding the exam? Stop share. Or regarding the upcoming exam? Wala kang tanong? Open notes ba? Actually, hindi ko pa nagagawa yung exam eh. Makakatulong ba? Sobrang dami ba para ano? Para ang tawag dito? Na pag-aralan. Okay, let me see. Teka. Dali lang. Give me just a couple of minutes. Open notes. Yeah, sige. Open notes. Okay. Open notes. No problem. Notes meaning, anong tawag dito? So, ililimit natin yun na para hindi kayo punong-puno rin ng papel at masyado kayo maraming hanapin. Okay, notes meaning you can use the textbook and yung notes lang natin sa klase. Okay, not your own notes. Okay? Is that okay? Yes, pwedeng digital. Pwedeng digital na notes. So yung pwede kayo magdala ng iPad tapos yun na yung or computer tapos yun na yung gagamitin niyo. Okay? Anong coverage? Ang coverage ay anything related sa Dirac notation at saka sa harmonic oscillator. So basically that's chapter 6. Tama ba? It's chapter 6 dun sa teka, tingnan natin sa book. Chapter yeah, chapter 6. Harmonic oscillator. Okay? Now, even though we covered it as chapter 6, it doesn't mean na kung ano man yung lessons na pinag-aralan natin before ay hindi nyo na aaralin. Okay, remember na ang workflow, 'di ba? Pagdating sa pag-solve ng mga problems is that we start from the Schrodinger equation. Okay? Then you solve you solve the problems. You solve the Schrodinger equation to get the eigenvalue and the eigenfunction. And then from the eigenfunction, you can get the expectation value of, for example, the position, the expectation value of momentum, expectation value of position squared, expectation value of momentum squared. And from there, you can also get yung tawag dito, uncertainties, di ba? In position tsaka momentum. Tapos, tawag dito, and you can prove na nasa-satisfy nila yung Heisenberg's uncertainty principle. At the same time, dapat alam nyo rin kung paano kunin yung kung paano mag-take ng measurements. So, of course, when you take the expectation value of x, you're essentially taking a measurement of the position, di ba? If you're taking the expectation value of momentum, you're essentially measuring the momentum, di ba? In the same way, if you take the expectation value of the kinetic energy, then measure nyo rin yung kinetic energy. And those lessons were from the previous coverage na exam. Dapat alam nyo pa rin yan pagdating sa harmonic oscillator. Kasi nga, that's essentially what quantum physics is. You solve, sa harmonic oscillator, sinolve nyo lang yung harmonic oscillator, but still you need to measure yung position ng particle within the tawag dito with a harmonic potential. You still need to measure yung momentum from a harmonic potential. Okay? So dapat alam niyo yung mga bagay niya. Okay? Okay ba yan? Gagamitin din natin lahat yan sa 182. Kung ano yung pinag-aralan nyo dito is really fundamentals. Okay? Fundamentals talaga yan. Sa 182, magsasolve pa rin kayo ng magme-measure pa rin kayo ng momentum, magme-measure pa rin kayo ng position. So solve nyo pa rin yung tawag dito, Schrodinger equation, magda-diagonalize pa rin kayo. Lahat yan, paulit-ulit nyo gagawin. Okay, so dapat hindi nyo makalimutan yung mga yan. Okay? Clear ba yan? Okay? So, any more questions in relation sa exams Monday? Wala. Okay, sige. Kung wala na, enjoy your evening, enjoy your weekend. Alam ko mag-aaral kayo. Hopefully mag-aaral kayo. And I'll see you next week. Okay?